Hi everyone, I'm Chaitra and I work on MySQL Optimizer. I've been with the team since 2011, so that's 3 years. And it's a very exciting place to be. So I will be introducing today to the major improvements that have been done in 5.7 with respect to both Parcel and Optimizer. It's just a glimpse of what can a user expect from 5.7 from Optimizer and Parcel point of view. It is not going to be covered in detail, but if you really are interested, you can just write to the group that I'm going to give you at the end of the session. We will give you all the details, and there are a lot of blogs that are written on all these features and a lot of work logs, information, everything is available to you. So if you are very much keen on knowing things, then just let me know. I'll just with the emails. So this is what MySQL Optimizer looks like. Like any other DBMS, it takes select query as input and gives out the most optimal plan for that query. So the first stage is parsing, where it is checked for all the syntax analysis and everything. And the next stage is the optimization. For optimization, we take a lot of inputs from the storage engine like statistics, how many records and how many rows for a single key value and things like that, nullability, uniqueness. All those things are going to be taken as input from the storage engine. So with all these statistics and the table and the index information, we usually make a cost-based decision, like whether to go with this access method or whether to choose another access method based on whatever the cost, the minimal cost for that particular plan. We are going to choose the most optimal plan. Say for example, in this case, for the given query, table T2 has range scan, table T3 has ref access, and that's joined together, and then the result will be joined with the table T1, for which the access method is table scan. So all these things are mostly cost-based decisions, but right now we do not have a complete cost-based optimizer, but we are more moving towards a complete cost-based optimizer. So rest everything is based on the heuristics, that is based on your statistics that are given by the storage engine. So the basic design principle, so whenever we are trying to introduce a new optimization or any new improvement, the basic thing that we have to take care is give the best performance, in a sense that give the best join order, choose the best access method for executing a particular query and everything. So that's one thing. And the second thing is always keep in mind that users should have minimal tuning for them to get the required performance. So not too many options for them to play around with, so that tuning is reduced. And the third thing is give useful information as much as possible to the users. That is, if they want to understand what is happening for a particular query. Say for example, you can use explain. So if you want to know plan for a particular query, what is the plan that is being chosen? And if you want to know in detail why it is being chosen, every decision point that as optimizer gone through behind the stage, you can use trace. So this feature is I think introduced in 5.6. You can use it to understand the complete optimizer decision making and all the cost-based decisions that optimizer takes. So that's trace. And then we also try to give a lot of flexibility to the users, so that if, for example, we introduce a new optimization and that is giving improvements to 90% of the queries. But say for example, for one of the query there is a problem and it's just not working and it's giving a very bad plan. So what do you do in those cases? We actually give hints, so that users can provide a hint to the optimizer saying that I want you to only pick this index, or I want optimizer to only pick this join order. Don't come up with your own join order. So things like that. Please stop me if I'm going fast. So things like that, all the flexibilities, like for 5.7 for example, we have come up with a query rewrite plugin. So you can use the plugin to rewrite all the problematic queries. So things like that. These are the design principles that are kept in mind before we come up with any feature. Okay. Okay, so this is the list of the improvements that are going to be discussed. So the first one is the parser and the optimizer refactoring. With the existing code base that MySQL had, there were not much of scope was there to improve upon. So a lot of refactoring has happened in the past couple of years, so that new features can be added with a lot of ease. So that's a major thing that is happening. Then we have for 5.7, the biggest thing that is being added is the improved cost model. So with the cost model, we have better record estimation for joins, which will actually result in better join orders. And there is also configurable cost constants. So based on your requirement, you can configure the cost constants and you can tune your queries. So it's tunable now. And there is also a query rewrite plugin. As I mentioned earlier, if there is any problematic query, you can rewrite the queries using this query rewrite plugin. Then you have explain on a running query, that is if there is a query that is running for a long time, I mean it's really taking a lot of time, you actually have to wait for the query to finish to see what is actually happening earlier. Now with this new feature, we have you can actually do an explain based on the connection ID and then just get to know what is wrong with the plan. Then we also have something called generated columns. I think it's available in most of the commercially available databases. That is, you generate virtual columns. Say for example, if you want to do not want to store a particular field, quantity into some query expression as such, which you are going to frequently use, but you do not want it to be stored. So you can use it, and this gets generated when you do a select automatically. So that's one of the things. And there are a couple of more optimizations. One for union all. This has been a long pending request from Facebook, and that's been addressed in 5.7. We no more create temporary tables all the time, irrespective of whether it is needed or not needed for union all queries. Then there is a optimization with respect to in expressions, and there is also optimization with respect to full text search. So all these things I'm going to be talking in the next few minutes. What's the motivation for refactoring the parser and the optimizer? The first thing for optimizer refactoring is that you need to clearly be able to visualize optimizer as this. That is, first there is a clear-cut parser which doesn't interact so much with the server. So, okay, you should try to avoid as much as possible. The server code should be independent of the parser. So that was not done, and that's being done in 5.7. Then there is optimizer, which has stages like resolving. Then you have logical transformations happening. Then you have cost-based optimizations, and then finally the plan refinement. So all these things were not happening earlier. Now with 5.6 and 5.7 refactoring, all these things are happening. There is a clear-cut distinction between all the stages of optimizations. And why is this needed? This is needed because whenever you introduce anything new, there's a possibility that you will introduce a lot of regressions, especially with respect to optimizer. So this gives a lot of flexibility for the developer to add any new features. So there's a lot of effort going on in refactoring so that it becomes more modular and it is more flexible for us to introduce anything new. So this is what the current MySQL Optimizer looks like, and these are the various stages. Okay, so what is happening with respect to parser refactoring? The main problem with the earlier parser what we had was that it was overly complex and it was doing many more things than what it is supposed to be doing. That is, your semantic checks and your interaction with the server, creation of items, lot of things that a parser need not have to do was being done in parser. Now with and because of this, what was happening is any parser bug that we come across is either it is very difficult to fix, and either it becomes very complex to work around the problem and things like that. And we were using Bison, which is usually good to generate a bottom-up parser tree, but that was used to generate a top-down parse tree. So all these things are clear now with the current parcel. You can see that there is a clear distinction between parse tree and then you have a contextualization which is happening in the second stage, and this results in an abstract syntax tree AST, which is going to be used by the executor. So there is a clear-cut distinction between the parsing stage and the optimization stage. So as I said, the solution to whatever the problems we had with respect to parser has resulted in fixing a huge number of bugs which were not possible to fix with the previous parser. So it is also enabled us to adhere to SQL standard more, and it also can support larger syntax rules now. So it's easier now. Okay, so the next big thing with respect to Optimizer in 5.7 is the cost model, the new cost model. And why we needed a cost model, new cost model. What was the problems with the existing cost model that was used in the Optimizer? What we had earlier was every cost was with respect to reading of a random page from the disk. This was okay, maybe a decade back or 2 decades back, but it's no more okay because you have new hardwares, you need the kind of data wherein you have scope for storing the entire data in memory. So you need to know whether the data is in memory. If the data is in memory, the cost will actually reduce, but you still actually what was happening with respect to Optimizer was that it did not know whether the data is in memory or data is in hard disk, data is in SSD, anything of this distinction was not there earlier. The only thing was, only way to calculate was with respect to random data page read from the disk. So with that, the motivation now is to, because of the new hardware architectures, you need to adapt to the new hardware architectures so that you come up with the plans that are more optimal, suited for the current hardware availability. And as I said earlier, there was no flexibility inside Optimizer to know whether the data is in RAM. If the data is in RAM, then how much is the cost to fetch the page, and if the data is in SSD, if the data is in HDD. I mean, all these things, nothing was there earlier. And what we had in Optimizer was we had cost formulas which are present everywhere, and we had hard-coded costs present everywhere, all over the Optimizer. So this had to be dealt with, and there was no way that user could tune or configure these cost constants based on his requirement. So all these factors together motivated for us to come up with a new cost model. So the main focus in 5.7 has been these key issues, the most pain points, as you call it. As I said, hard-coded cost constants which could not be tuned, which could not be configured to users' requirements and cannot be adjusted to different types of hardware. So that is being addressed now. And then the next thing is cardinality. So when I say cardinality or records per key, this is the most important statistic that the storage engine gives the Optimizer. So what is record per key? For example, if I have a where condition on a field which is uniquely indexed. So what happens? You are looking at, for every key value, you are looking at, say, one row. But whereas if I have a non-unique index, how many rows am I looking at per key value? That Optimizer has no way to know. So what happens is that storage engine gives it an estimate, saying that you are probably looking at 4 or 5 values for every key value that is being indexed. So this was earlier an integer value. So if I have a cardinality of 1.1 to 1.9, that is your records per key is 1.9 or 1.9, both of them used to get the same cost. But whereas in reality this matters a lot, because this can be the decision point between the optimal plan or a bad plan. So that is being changed now, so that it accepts a floating point number, and then based on that you have the cost being calculated. Then the third thing is inaccurate record estimation for join. So earlier what used to happen is we used to not take care of lot of things whenever we are joining two tables, like the where conditions that can be applied, and we always used to overestimate the number of records coming out of a table. So because of this overestimation, again the join order might be a problem. So this is being addressed. And then hard to obtain the detailed cost numbers. So if the user wants to know what is the IO cost, actual IO cost, if the user wants to know what is the row evaluate cost or a compare cost, and all these things, the details of the cost numbers, this was very hard to obtain in the previous optimizer. So all these things were addressed. So here is an example of record estimates, how we have improved upon. Okay.
What was the hard-coded cost?
Say, for example, you have for a random page read of a disk, you have one that is taken as 1 unit, and you have compare cost, row evaluate cost. So, for example, after you fetch the data, now you have to compare the keys. So, what is the compare cost? That is 0.2, and there is sorting of the keys cost. That is 0.1. These are all hard coded.
How do we decide that?
So the cost is always with respect to, if you take the time taken for reading a random page in the disk as 1, how much am I taking actually for comparing? So you take that as 1 and compare it with this and come up with a percent. So it's 0.2. So that was hard coded earlier. Now it is more like we can tune it, and we have come up with the APIs, which actually makes it more tunable, and even you can give SSD cost and hard disk cost, or you can give memory cost, all kinds of costs you can. But earlier it was not possible. It was always 1 and just take. So this is the improvement that I was talking about overestimating of the resulting records from the join. So here is an example. You have 2 tables participating in the join, T1 join T2. So what was the total cost in 5.6? How it was calculated is, you have a cost of the access method that is used for T1. So you have chosen a particular access method to scan the tuples in T1. So the cost of that access method, plus for every row that is being generated out of T1, you need to multiply it with the cost of accessing T2. So for every row that is being generated from T1, you are going to see whether these many records are present in T2. So you are going to come up with a cost formula, that is cost of access method for T1 plus the prefix rows. The prefix rows is the number of rows resulting out of T1. Not every tuple in the T1 will be participating in join with the T2, right? So all those rows that are resulting from T1 multiplied by cost of the access method for T2. This was the formula that was used earlier. Now what is improved and where is the problem? So what if I have where condition on this first table? The T1 has a lot of where conditions which actually filter out lot of tuples. Say I have, the first estimation was that I am going to be looking at 10,000 rows, and after applying the where conditions I am actually looking at 50 rows probably. So what is the final cost should be? Final cost should be 50 rows into the access method of T2, right? But earlier it was 10,000 into access method of T2. So because of that the cost used to vary for a particular plan, and based on that, and based on that actually we used to make the decisions. Now what we have introduced in 5.7 is something called condition filter. So what is this condition filter? Condition filter is it is going to give the idea to the optimizer about the percentage of the tuples that are probably going to be finally given as input to T2 when joining with it. Okay, so you come up with a condition filter value, and you are going to multiply with the number of records that are present in T1, and that will be your prefix for joining with T2. Okay, so this way we are actually getting to more accurate join orders.
How do you know that
Multiplication, the condition filter. Say for example, okay, I will just give you the example. Okay, so these are the 2 tables. Okay, the employee table has 10,000 rows, and office table has 100 rows. And for now you just forget about the where condition. So the 5, 6, what used to happen was, since office is having just 100 rows and you are actually joining on a primary key, you just go with office because it has less number of rows, 100, and then employee has, for every row of that is selected in office ID, you are going to check whether there is a matching row in employee, and then you finally apply the where condition. So this was the join order earlier chosen. The first table was office and the next was employee. Now what happens in 5.7 is that the join order has changed. And why is that? Now we are going to, with 5.7 what we are trying to do is, we have an estimate. Whenever we are trying to choose an access method for a particular T1, we always have estimated, we would have actually gone through every possible access method to choose from. So each access method will give us an estimate of how many records are you going to look at if at all you go with this access method. So for example, you have a where condition here. So if I go with a range scan, what is the number of records that I am going to look at? So based on this, we are going to come up with the percent. This 1.23% that you are seeing is the estimate given by the range optimizer. Did that answer your question? So whenever we are trying to say, for example, you just forget about the join. Okay, I have just select start from T1, where condition, so and so. Now whenever we are trying to see what is the possible access method, best access method to choose from, you are going to check the statistics with respect to the where condition. So do I have an index on hire date, or do I have an index on name? If I have an index, what is the estimate that the storage engine is giving me for this particular index? Say for example, if it is a non-unique index, it is going to give us how many records are you looking at per key value. So based on that, you are actually going to come up with a number of records that you are going to look at for every access method. So based on this, you can estimate, say your range scan is going to be out of 10,000 rows, you are probably looking at 100 rows, then your range scan's row estimate is 100 rows. So based on this, you can actually come up with a percent. And whenever we do not have any index information, we do not have any kind of help from the indices, we are going to guesstimate. That is, we are going to guess a particular number. We have some standard constants that are going to be used. So they say this much percent is usually what the data is going to be for this key value. So based on that. So you came up with a condition filter that is 1.23%. So that is the percent of the rows that you are looking at probably out of the 10,000 rows. So based on that, the join order changes. So this way, whether it improves every query, no. But we are sure from now on that it is going to be more accurate than before. But definitely for couple of queries you see here, DBT3, out of 22 queries, 5 queries have improved join plan because we are more accurate in estimating the join records. Did I answer your question?
No, it's not very clear for me actually.
Okay, I can just explain it to you later on. Okay, so this is also another improvement. As I said, now we are able to get very detailed cost numbers. So whenever you have an explain format equal to JSON and your query, it is going to give you all the details. What's the read cost and what's the evaluation cost, what's the prefix cost, and the amount of data read per join. All the information now is available. It was not available earlier on. So this is the cost model, and this is how the visual explain looks in MySQL Workbench. It is clear cut. It's very easy to understand. I don't have the first table. You can see that there is a table customer, and for every key value you are actually looking at 300k rows. So this is the output from the previous table, that is 10 rows. So the output from this table is probably you are looking at 10 into 300k, so 300k rows, and what's the cost, like that, so on and so forth. So you are going to get a clear cut understanding of what is happening. Okay, so far any questions?
You mentioned you use Bison.
Yes.
So was that changed or?
No, it's the same thing. The problem was that Bison is usually good to come up with a bottom-up parse tree. That's natural to it. And you are trying to do something that is not so natural. Because of this, we had lot of shift reduce conflicts, and every time you try to introduce your new grammar or something like that, syntax rule, you are going to introduce a conflict. So it was more for historical reasons that it was done that way, but now it is changed. Now it is.
So what changed? How did we fix that?
Now we are they have refactored the whole parser code so that it gives you a bottom-up parse tree itself. There's no top-down now. And then there's a distinction between contextualization and this. Okay, so as I mentioned earlier, not every optimization that optimizer introduces will have only good plans being generated. There are particular queries that can have problematic plans. So what do you do then? You actually go back to the user and suggest them to rewrite their query. That is, if you are using subqueries, make it a join, or you are going to, or you want only this index to be used, then just force index. You can just give a hint to the optimizer saying that use only this index, and you can force its join order. But many a times for user, it's not possible to rewrite his query, because this query might be coming from third-party applications. So what do you do then? So there were a lot of requests wherein we are not able to change the query, just do something, or so that you come up with a optimal plan. So for that, there is a query rewrite plugin that is given now with 5.7, wherein it actually rewrites the query, adding the hints. So this is a post parse query plugin. So user can tell that this is for a query like select star from T where so and so condition. You can rewrite the query to select star from T1, force index I1 where so and so. This is this he can give instruction to the plugin, and then the plugin will take care of comparing the queries. Whenever a query comes, it compares, and then it going to replace it with a pattern that the user has given. So this is done now, and you can add hints, or you can add modify the join order and anything. So this is, sorry for the format, I had some problems with the format issues. So an example here is you are force index and you are introducing a straight join between T1 and T2, and you are going to tell the plugin that for a query which is so and so select star from T1, you replace it with this pattern. So the literals are usually not considered for matching. Usually whenever you are storing in, we are going to replace it with question marks. I think we are right now using performance schema statement digest, I guess you have, right? It's similar to that, the same statement digest is used. So how does the matching of rules happen? So there is a query digest that is going to be used, and for every query that you have, there is going to be a hash lookup that is going to happen. If the hash value matches, then you pick up that particular pattern, and then if there are hash collisions, then you actually compare with the parse tree structure. Again, if the parse tree structure is the same, then you actually finally compare the literal constants, and based on that you can finally the plugin will tell you whether it is being replaced or not. A note is going to be generated, like if you say show warnings, it is going to say that this thing was changed. So this is how the query rewrite rules table actually looks like. So you actually insert to this particular table saying that insert into rewrite rules table a pattern, and then the replacement, and say that this is the pattern and this is the replacement. And if at all there is any problem with the query itself during parsing, it is going to raise the parse error, and you can see in your warnings. So what is changed from the server's point of view with respect to the query rewrite plugin? So the query comes in, it is going to ask the plugin whether it wants digest. So if it is requested for digest, it is going to generate it, and then query is parsed, the plugin gets invoked, and the pattern matching happens, and if there is a match, the query gets rewritten. And there is no additional overhead for queries which are not rewritten. Only if it is only going to be a performance overhead only for those queries which needs to be rewritten. So, and this is a very minimalistic query rewrite plugin. This is to just address the problems with respect to a problematic SQL query, not in a way, rewrite completely into a different thing altogether. So just add some hints and execute the query. So as I mentioned earlier, we have a feature now which gives you which can be used to run which can be used to do explain on a running query. So if a query is running for a long time in one session and you want to see what is happening, you can just give an explain for that particular query with the connection ID that you get it from show process list or something. And this is, as I said, useful for diagnostic purpose for long running queries if you want to know, and it's applicable for all selects. So we have something called generated columns, as I mentioned earlier. So this was a community contribution which has been improved upon by one of the developer. So this is something like, as the example says, you have the sum of the total, the total amount that needs to be calculated every time for this particular order. So what you are going to look at is every time you want to calculate, you are going to multiply quantity with the price. So what you can do now is you can just make it as a virtual column, or you can make it as a stored column. So virtual column is only when you are actually fetching, reading the data from the table, it is going to get calculated. So this is the virtual, and you cannot index it or you cannot store it or anything. And if it is stored, then you can index the column as well. And this is useful for something called functional indexes. A functional index is something like, say, okay, I'll just give you an example. I have a function like, say, upper name equal to something, some name in the uppercase. So you're going to actually convert the name from lowercase to the uppercase and then compare it with it. Now you have an index on this name, but this index will never be used because it is used inside a function. So now with this virtual stored column concept, you can actually generate an index for upper name, and then you can start using that index, thereby improving your performance of the query. So that's useful for functional indexes. And if there is a complex condition that is needed every time, so you can actually give as input and then store it and then retrieve it. So there's one more optimization. Union all queries always used to create temporary tables, irrespective of whether they need sorting, whether nothing was taken as a requirement for creation of temporary tables. So so now with this new feature, temporary tables are avoided whenever possible, and because of this, I think Facebook, it is a long pending request from Facebook. So it was to address that problem, and because of this, you less memory and disk access as well. And one more key improvement is with respect to in expressions. So you can see the query here: select a comma b from T1, where a comma b in 0, 0, 1, 1. So what is this query? The where condition would be something like a equal to 0 and b equal to 0, or a equal to 1 and b equal to 1. This is the where condition that is actually user wants to give to the server. So what it expects the server to use the index, but it was not using so. Now with this new optimization, you can see that even for the row comparisons, we are using the index, and this is what the plan looks like. So earlier it used to fetch all the 10,000 rows from the storage engine and then execute the where condition. Now it actually pushes the where condition down to the storage engine itself. So this is the final optimization. So for full text search, earlier there was no optimization at all done from the optimizer point of view. Now we have just started giving some kind of hints to the storage engine so that they avoid sorting or not to do many things that they were earlier doing. So in case of count star, you are actually not requiring to do the ranking and sorting, and all those things are not required. But it was earlier doing. Now we optimizer gives hints to the storage engine so that it doesn't do all those things. So because of this, we have an improvement for such queries. So this is what you can see in 5.6 and 5.7. You can see that there is a hint, full text hint given to the optimizer. Storage engine. Okay, so that's all I had. But if you have any questions, you can just ask me. Can you change the table name?
Query rewrite.
Query rewrite, yeah, that's what. You say select star from T1 where, and then you have a select star from. I don't think that is optimal, right? For any table, you do not want to force an index. See, select star from T1 where some field equal to this, and I have chosen a index. So the optimizer has chosen an index that is not optimal for you, for that particular table. Now, if you want to rewrite it, you are going to say select star from T1, force index I, so where this. Now, if the table, if we give an option wherein the table can be anything, then you are going to replace it with select star from, yeah, so, and force index I itself, right? The index is not there with respect to that particular table, and it no more holds good as well. See, this is for to address problematic queries. Like you are hints. Mostly, see the motivation for introducing the query rewrite itself is because there's a new cost model that is being introduced for 5.7, and most of the time it is we are sure that it will give you the optimal join order, but there are going to be problems for particular queries. So for those queries, if somebody upgrades from 5.6 to 5.7, if the orders change, join orders change, or if the index plan changes, just use the query rewrite plugin to just give those hints, and it's a very minimalistic query rewrite plugin just to address those problematic queries. That's it. Anything? Yeah.
Query plan changes will happen, right? Is there a way where we can raise it and
Is there any way?
like for example, in Oracle there is one right where the plan change we can raise and we can opt the better plan. If any plan change happen.
If any plan changes, how do you opt for a better plan?
Yes.
By giving hints?
Yeah. Is that how we can trace it, and that option is always.
Say I did not get your question. Say I have 5.6 version right now, and I have a query that is executing fine, and I have a plan. Now you upgrade to 5.7, and then there is a query plan change. Is there any way to detect it?
Detect, and is there any way where we can manually push that query to opt some better plan?
Manually, I am not really sure about automatically detecting that the plan is changed, but definitely to enforce the previous plan, there are hints, but not to a very great extent like Oracle or any other commercial databases provide, but we are getting there. The hints are there, like you can force the join order, you can force a particular index for a particular table, things like that, you can just use it. Anything? Okay, then I'm done, but if you still have any questions, you can just ask me after the next session. It's fine. Yeah. Thank you.
My name is Venkatesh. Okay, so I'm going to talk about multi-source replication feature, which we introduced in 5.7.5. Currently, it's in MySQL Labs. So I will explain what is about that MySQL Labs. You can ask me questions anytime except for this slide. So you have to read it, and I also will read it. Okay, so as I said, this feature is on MySQL Lab, and MySQL Lab feature is not fit for production. It just we have kept it in MySQL Lab just for the testing purpose, and so please don't use it in the production. And if you want the production ready binaries, you can go to MySQL downloads page in the MySQL site. Okay, so before I go to the actual feature, multi-source replication. About replication. So why do you need a replication, and what is a replication? Let's say you have a master, the main server, and let's say you have one more server, which we call it as slave, and you do something on master which will be replicated to the second server, which is we call as slave. So now what we call it as master and slave, there is a replication happening. Why do you need replication? The main purpose of it is redundancy. If master crashes, promote the slave to the master so that the data is not lost. For example, you have done something in Facebook status, and say for example that is lost. Obviously you will be disappointed, and you don't want to happen that. So you replicate the data, and if something happens to the master, you get the same data, whatever you have written there, get it from the slave, and using some tools, failover tools, that's what we call it as, you bring that slave as a master. That's the main purpose of the replication. And another purpose is read scale out. What do you do is, so you have a master, you have a slave. Let's say you have all the clients, write clients connected to the master. Let's say this is insert into T1, insert into T2, insert into T3. This is insertions are happening, and some people wants to know the data, so they will be read clients. So let's say, as you know, in the real time, there are more number of people who are viewing it the number of people who are actually updating the data. So obviously you want to scale out the reads. So in that case, what do? You add so many slaves, and then you can just, how many you have now? 6 clients. So it's kind of read scale out. That's the another purpose what you do. And if you want to do a write scale out, we have another feature called MySQL Fabric, which is recently GA'd. So that will be last Usercamp. I think we have given a presentation on MySQL Fabric. So this is a different. Okay, another feature why do you need a replication is online backup and reporting tools. Somebody wants to do some business intelligent client apps, reporting client apps, or BigQuery client apps just for the reading purpose. You don't want them to happen on the master.
So this application is immediate, or it takes some time to?
It's immediate. I mean, network delays and all those things. If you just ignore that network delay, it's immediate. There is a feature called delayed event, where some cases people wants to happen little delay. That's also there, but by default it's immediate if you ignore the network latencies and all this stuff.
So discuss the technology used for the application.
Sorry?
We'll discuss the technologies using for the application.
This is just the background. The main purpose of this presentation was like introducing the multi-source replication. But if you are interested, there are a lot of blogs. Even after this presentation also we can discuss if you are interested in some particular technologies which we used it for the replication.
Is there an override if I use this feature?
Sorry?
Is there an override when I use this feature as compared to the standalone model?
In a standalone, if there is no replication, all the data will go into a storage engine logs. But in replication, we store it in a separate log called binary log. So there will be a little bit overhead. I don't say it's like 0% overhead, but there will be a little bit, but it's not noticeable. You can just ignore that now.
Will that overhead increases when I have more number of slaves?
More number of slaves? No. It's just that one more thread will be reading about that packet.
But that also adds some overhead to the process, right?
Yes, as I said, there will be overhead. And if you have one more slave, there will be one more thread reading the same file. In that aspect, there will be a performance impact, but not.
Maximum number of slaves that I can have in the system.
That depends on your hardware, how many threads it will support. If you add one more slave, obviously you need some threads to it. So there will be a hard limit, but there is no soft limit. It's like if your machine is little slower machine, like you have only 2 GB and you have only 4 CPU, you can't obviously add like 8 slaves because you need so many threads and thread contention will happen and there are a lot of other problems. As said, there is no soft limit, but the hard limit related to the hardware, whatever you have. So other purpose is that online backup. You do the backup at the slave so that you don't disturb the master. That's the main purpose of the replication. Okay, since there are more questions on it, I will give a little 5 minutes thing what happens on master slave thing. So now on master, as I said, if you have insert into T1, T2, T3, 3 tables, there are 3 transactions happen. All those 3 transactions will be written to a log called binary log, which is different from the actual storage engine log. This binary log you have. And now let's say this is a slave, a separate slave, which the slave wants to connect to the master. There are some certain commands where you can connect to this level. What happens when you connect? The moment you connect, there will be a thread called IO thread on the slave. There will be a thread called dump thread. And there will be a thread called SQL thread. So 3 threads. One is dump thread on the master, 2 threads on the slave, IO thread and the SQL thread. So what will dump thread do is, whenever there are some updates on the master, it will dump thread will identify it and it will put it into the IO thread. So IO thread will retrieve it. IO thread will put it into the another log on the slave, which we call it as relay log. The same data will go on, but the naming is relay log. And as I said, there is a third thread, which we call it as SQL thread. This SQL thread is nothing but it reads this log and then it applies to the server. So it's like this SQL thread is like another client to the slave server. This is a little background about what happens on master slave.
How is the consistency ensured between master and slave? Can there be lost updates between them?
Unless you have some bugs. It's like whatever happens on the master will go there.
But it's always pushed, right? So any update
Yes,
on
yes.
master?
It's like dump thread will detect it automatically that there is something and then it will put it.
It's a pull.
It's a pull mechanism, it's not a push. You are pulling from the slave.
Yeah, it's dump thread will identify the number of
It's done by
transactions
done
happen.
by the-
Sorry?
Yeah, I think should be moved to the main content of the doc and take these things out.
Okay, so different types of replication server setup. You have one kind of setup is master slave, another one is master and number of slaves. Another one is a chain replication, which is master connected to another master and then connected to slave. And then 2 masters connected to, one slave is actually connected to 2 masters, and another one is 4 masters connected to each other. So this is the one which we call it as multi-source replication, and this is multi-master replication. So till 5.7, we don't have support for multi-source replication and multi-master replication. So now in this presentation, I will be giving an introduction about multi-source replication. Okay, so as you know, as you see, there are 2 masters connected to the slave. Earlier, there is no support for that. So before this multi-source replication feature, how people used to do is time sharing replication, where a slave would connect to a master for a particular time slice. He disconnects, and then again a new guy comes and he connects it. And then whatever the updates happened on the master to that the slave will get the data from the mother, for the master 2. Again, it will move to master 1 like that. So obviously, as you can see, it's a pain. And another one is like this, M1, M2, M3 slave. If you are interested in getting the data from M1, M2, M3, you can do a chain replication. But as you know, there is too much delay from M1 to M2, M2 to M3. It's like 3 in the chain, which will be delayed. And there is some other ways of, it's really a difficult way of doing it. Like you get the data in MySQL binlog, transfer it to the other place, and then you apply it using this MySQL binlog tools and using some new feature called global transaction. So all these 3 ways are a little tough, and then lot of requests coming from the community asking for multi-source replication feature. So what do we want in multi-source replication is receive transactions from several MySQL servers simultaneously via communication, several communication channels. That's what we are mainly looking for. At the same time, we want the data from, not like time slice. And apply these received transactions. And actually, multi-source, according to the multi-source replication, they don't care about conflicts detection and resolution. If your application is looking for conflict detection or resolution, there is another feature we have released it recently. It's actually in the labs. That's called group replication.
Can you give some business example of multi-source?
Yes, that is excused. Yeah, so just to repeat the last one, if you're looking for conflict detection thing, there is another feature which is called MySQL group replication, which you can download it from the labs. I think after this introduction, we have use cases. I will explain the use cases. Okay. So as I said, slave can have more than one master. You have DB1 on master, DB2 on master 2, DB3, DB4 on master 4. And then slave will get DB1, DB2, DB3, DB4. Whatever the updates happening parallelly on these things will come to the slave. That's one of the use cases you can see. Okay. So data aggregation, database 1, database 2, database 3, database 1, 2, 3. You can have whatever you want it on this slave. That's one use case. And another one is you have actually the data is shared, and then you can get the full table here. So because you have a full table here, that will give you online backup. I mean the full backup here. You can do a full backup here on the slave, which you can't do it on any of these. That's the main use case you can.
What about if engine changes?
Sorry.
If engine change, how it works? Yeah, if it's multiple engine used, how it works?
Some storage engines related. It doesn't matter. It's insert happened on T1. That T1 is here. It's if it is an InnoDB engine, it will be an InnoDB table here. You have an insert here that comes here and then gets updated.
So basically, when when this is written to Bangalore, it is actually something called a transaction, so which is independent of the storage. So when it is transferred and it's supplied, it is based on the storage engine that is used in the slave, not on what is there on the master. Of course, there might be some issues. For example, if you are using backward engine, there might be some differences. You cannot send reads on the master, you can do it on the slave. But then more or less functional. There will be no operational component.
So let's move to internals of the feature. So receive transaction from several MySQL servers simultaneously, apply transactions from different masters simultaneously, and no conflict detection. And this one. So the same thing whatever I said. Client, it did insert, it is written to the binary log, and this is called sender thread, which is we call it as dump thread. And there is a receiver thread, and then on the network you have it's reached the slave, which we will write it into the relay log, which is This is called relay log. The same insert is here. And then applier thread, which is SQL thread, will be applied to it. And then there will be another binary log on the slave, which will be returned to the binary log. So this insert is traveled this path and then reached here. If there is another server connected to it, that again will go to the next one. That's the main. So now there is a term which we introduced in multi-source replication, which we call this particular part of the path as channel. Okay, so the number of channels on the slave is number of sources. And in MySQL there is a feature called multithreaded slave and then single-threaded slave. That SQL thread, as I said, the SQL thread will be applying the data on the slave. Right? There is a feature called multithreaded slave where you can, SQL threads can be n number, so that all the n number threads will read from the relay log and then they will apply it parallelly. That is to increase the performance, so that there will not be any delay. If there is some 100 clients connected to master and they are doing it, if only one thread is applying it on slave, it will be a delay. So you have a multi-threaded concept there. So in single-threaded, you have single applier. This multi-source replication is supported for multi-threaded slave applier also. So in one channel, you can configure to have n number of SQL threads. Okay.
So what is the bin log linked to the slave?
That's the slave's bin.
Okay, slave also captures bin log.
Yeah, if slave is configured as, it can become master in future, then you have a binary log. Otherwise, you don't have a binary log. That's like -- log bin if you start.
No, optional, right?
Yes, it's optional. But just I showed that to show that insert here is actually applied on the slave.
So now, Videsh, can you show me the PS?
Yeah.
So, Pragati, you were saying that for a particular thread, channel, you can have this multiple SQL threads also.
That's right.
But as per this multiple thread SQL this replication, that works for if you had the n number of this SQL thread is actually equal to the number of this database. Am I correct?
Actually, there are features where we actually have a database parallelism, even you have time slice parallelization.
Because I don't think it will work for this multiple number of this tables. It works for a number of.
We have introduced a new feature in 5.7 where it works inside the one database can be parallelized.
SQL threads.
Yes. We have introduced in 5.7. That's called time slice optimization.
Not sure if you change the name. It used to be.
Okay.
Yeah. So we do have a facility to parallelize inside one database. In 5.6 it used to be like across the threads only different databases in 5.6, but in 5.7 we do have that.
Basically, we are not doing any kind of conflict resolution detection or anything. So basically, even if there is a conflict, there is a requirement of the application to make sure that there will be no conflict based on the architecture, based on any deployment. So if you're writing an application and you're modifying the same database in two places, then there might be a conflict when you are running on the slave. But then MySQL will not do anything based on that. The application should make sure that there is no that.
So you mean a single table will not be updated at a time? Multiple times. Multiple threads will not be.
Masters, so the same table will not, or rather, I should say, the same database should not be updated. For greater consistency. The same database should not be updated into masters every day.
If those transactions are not did not happen parallelly on the master, we have a mechanism to detect that and can apply it on slave parallel. So we have a mechanism to do that.
Major use case might be write scaling. This can help us to scale writes, the multi-source replication. Like we divide our master into multiple chunks and update there and get everything on the slave.
That's right, but when you say write scale out, right, people generally go for multi-master, where the fifth one which I showed, 4 guys.
We are going to cover that.
No, in this presentation. That's a MySQL group replication separate thing.
So this is more of a sharded application. I mean, if you have a sharded application or you have a sharded database, and then you want to use this is very good. So we actually had this use case where we wanted to use this for write scale, but it didn't happen because most of the time when you have an application, you will have. I mean, if you want to distribute a single schema into multiple servers, right?
That's
And-
shared.
Yes. Right. So not that unless you're using
We
sharded.
can use it in MySQL Fabric.
Yes, MySQL Fabric is pretty new. We do not use it. We generally use this for data warehousing, OLAP. OLAP is very big.
So bringing everything in once.
Warehousing is like the actual use case.
This structure not create one conflicts and data integration issues that so many source and one target. Data coming from so many databases.
So exactly. So when we say when MySQL says that you can do this, we actually specify that you cannot do any conflict resolution. We will not do any conflict resolution detecting consistency. We will not do that. If there is a consistency issue, if it is the data coming in does not follow as property, then the slave will stop or the particular channel will stop and there will be manual data.
For multi-tenancy applications, will it suit?
Multi-tenancy, we have not sure.
I mean, this does not have any HA also, right?
We have MySQL Fabric is.
Fabric, we have a MySQL Fabric, we have MySQL group replication. This is mainly for starting. Sorry?
You can have almost name. You can have almost name.
Maybe one master tree, not exactly applications.
You can.
That depends on your thing. It's just a slave. You can have one more slave also as a master, whatever.
Every master can have
You can set it. It's just a slave. Depends how you design your application.
One slave and multiple masters.
One slave. So this is the feature that is one slave and multiple.
One slave and multiple masters can connect.
One master, multiple slaves.
Yeah, you can have.
Actually, in all MySQL deployment that I have seen till now, every master has to have a backup slave, and that's like a given because anything you do, you cannot actually have a availability greater than 3 days if you don't have.
But M1, M2, M3 also they have a different data, right?
But you can have this one slave.
But if
per
M1 is
master.
down, how they can somebody can access as slave? Because that their structure is different. It's not exact reference.
No, I'm saying you can have one slave for M1, one slave for M2, another slave for M3. These slaves.
In that scenario, it is like a replicate, but in this scenario, I think all
He's
three
not
databases.
explaining that. He's explaining only the concept. He's not explaining that. Depends how you.
This is the simple setup what we can explain now in the simple terms. We can extend this with n number of masters and n number of slaves. Okay, so how do you create a channel between master and slave? There is a command called change master, which is an existing command, and we added a new clause called for channel. So you specify some channel name, and then we create the channel between that master and then slave, and then you do a start slave on the slave, which will start the IO thread and SQL thread, and it will do that work whatever it is supposed to. And a few things which about this channel are case insensitive, and then special characters can be used, and then maximum number of channels is 256. This is just hard-coded number because in the real use case nobody really wants to have 256 channel anyways. Okay, so commands, mainly the existing commands we just extended with this for channel, like start slave, IO thread or SQL thread for channel so and so, and then stop slave, reset slave, all flush relay logs. There are a lot of commands in the replication where we extended this with the for channel thing.
Can you please go back to channel?
It's like you just name it, like you have 3 channels here, right? This is one slave. You want to bring down one guy. You have to identify this guy, right? You have 3 channels here, you have to identify, name them, so that on the slave you can individually bring them, or you can bring them up. Just to uniquely identify these channels, we have channel name.
So you have default channel for looking at backward compatibility.
Yes, yes. Yeah. And these are the commands which we added the clause. And there are few functions which is master position wait. There is some functions like wait until SQL thread after GTEDs. There are few functions like this, and we added an extra argument for it, where you have to mention channel name, so that master position wait on this channel. So working with all channels, say for example you have 3 channels and you want to bring down all the 3 channels, or you want to see some slave threads, that's also we have support. Like start slave, SQL thread, IO thread. If you have 3 channels, you can actually say start slave, which will bring all the 3 channels, IO threads and SQL thread. All these things you have. This automatically will give you backward compatibility if you have only one channel, which we named it as default channel. So if you don't have this feature, multi-source replication, nobody wants to use it, it's actually a default channel, and then someone says start slave, SQL thread or IO thread, you can actually say, okay, you have only one thread, and then user wants to just start that one thread particularly. So as said, there is a error. If you are getting an error called ER slave multiple channels command, what does that mean is, these are some examples of it. This means you have executed something, but you have more than one channel, and I don't know which one to start, which one to bring up, or which one you want actually relay log events. If you have only one channel, for the backward compatibility there is no issue, it will run without any errors. But if you have more than one channel, we will error out. So if you are using this feature and if you get this, that is, the reason is you have more than one channel and you did not specify for channel keyword.
So how will I monitor this? So basically in stores, right?
Correct.
You got that?
Yes, I have. I have that next slides. So these 2 things, again we have for the backward compatibility, we have a master position wait without that extra channel name, and if you don't specify, and if you have more than one channel, again you will get the same error. That's for the backward compatibility. And now we have several features, features in replication. Multithreaded slaves, which I said earlier, and then there is a global transaction identifiers, and then semi-synchronous replication, slave repositories, filters. These are the major things which multi-source replication is interacted with. And we have, for the current version, we have compatibility with all those features. Everything is yes, and I will explain why I have a star there.
Excuse me. So what is slave?
Okay, so multi-threaded slave, we are supported, there is no star in the previous slide, and then if you have parallel workers K and you have M channels, you have K plus 1 into M applier threads running. And GTEDs, there is no issue, but there is only one restriction, which is like all the servers in the form have to be in the GTED mode on. They have to be on the GTED mode. If there is anybody who is with GTED off, there will be a problem. And then the another one, this is also supported, but with a restriction that anyone who is participating should be in semi-synchronous mode. In the sense, you can have all the people in asynchronous, that's also fine. But when it comes to semi-synchronous replication, we don't support few people with asynchronous and few people with semi-synchronous. And then filters, it's also supported, but you can have filters globally. Like you have 3 channels, you can specify one global filter, which is applicable to all 3 filters. So we are looking into those features, which we said would start. But right now, this is the feature we have. Any questions? So we have filters like replicate, rewrite DB, replicate do DB, replicate ignore DB. One master and one slave. You can say that replicate only a DB1. I don't care about DB2. There is features like filters like that. Now you have two masters and then one slave, and then on this you say set replicate do DB is equal to DB1, which you are saying that I want only DB1. This is global, like you can't specify individually, like I want DB1 from here, ignore DB2, but I want DB2 from here, but ignore DB1. Those kind of individual settings are not yet done.
But we have planned to do that.
We are thinking about it, we are looking towards that.
Venkatesh, I have a question regarding 5.6. I had one bug I've seen. I haven't got any update from that bug, that's why I'm asking. There was an issue with the multithreaded slaves and compatibility with GTID and multithreaded slaves. That issue has been solved because I didn't got any update from that.
Maybe after this session we can discuss it. If it is multi-threaded slaves and something GTIDs, then we will discuss after this, if it is okay. Okay, and slave repositories, we have two different types of repositories supported in 5.6.5.7 book. One is table repositories and file repositories. Multi-source replication is actually supported on table repository, which is a crash-safe slave. If you have a table repository, that is a crash-safe slave. So we are supporting only table repositories. If you start the server with file repositories, and if you want to use it for multi-source replication, that is not supported. So to start with the table repository, these are the options like master info repository, relay log should be a table. And for example, you can, if you say like I have file repository which is running, but I want to use multi-source replication, how do I do it? So you can do it, all you have to do is stop the slave, stop the slave SQL thread and IO threads, and then say I want to change the repository into table. So we will automatically we will convert the file repositories into table repositories. Once it is done, then you can say start slave, and then it is ready to use for multi-source replication. Let's see a simple setup how a multi-source replication. This is a pretty simple, and obviously but in real use case you have more number of masters and then slaves. This is just a simple setup. You have 3 servers, and let's say you the ports running 13,001 and 2, and then let's say you want these 2 are masters and this is a slave. On slave you execute change master port 13,000, and there is so many other things which you can specify, and then the new one which we added is for channel, and then you name it. You can name it anything, channel underscore name, anything is. And then what happens? Channel is created between master and slave. Next, on slave, you say start slave for channel underscore m. For channel you specify. Then what happens is IO thread is created, and binary log, master's binary log, you have insert into T1, that will be written to slave relay log, insert into T1, and there will be SQL thread which will be looking into it and applying it. So now, earlier what you can't do, now you can do is, when this is happening, you can say change master port 13,001, and then you have another channel, which was not possible earlier, but now you have, it is possible. So same thing. So your channel M2 is created, and then the moment you say start slave for channel underscore M2, IO thread will be created for this channel, and then insert into T2, which is in master 2's binary log will be written to the relay log by IO thread, and then SQL thread for that channel will come into picture, and then it will apply. This is a simple setup, and with these commands you can do a multi-source replication. And as you can see now, you have insert into T1 some other one, and insert into T2 something on master 2. they are parallelly coming here without any problem. Okay, now coming to the monitoring part. I think you asked for the monitoring, right? So in 5.7 we have introduced performance schema replication tables, which is mainly for monitoring purpose. We have introduced mainly 6 tables: connection configuration, connection status, execution configurations, execution status, and then for the multi-threaded slave we have 2 more tables. These tables are not only for multi-source replication, for so many other features we are actually having, you can monitor all those features in these tables. And let's see how we can use these tables to monitor multi-source replication. So these are the tables which we have, and almost all the tables are almost in the similar lines with the same different columns, but almost on the similar lines. So we will explore one table which will give you a clear idea of how you can move to some other tables if you are interested. But as the name says, these 2 are related to connections, these 2 are related to execution, and these 2 are related to MTS. If you are interested in knowing about the connection between a master and slave, you have to look into this. If you are interested related to something to do with the configuration, first table, status, second table. So like that. So let's take one table example, connection status. So as you can see, select star from performance schema replication connection status will give you n number of channels, n number of rows, 1 row for 1 channel. So channel 1, some data, and then channel 2, some data. If you have n channels, you have n number of rows. So this is source ID and this is thread ID, and then service state, is the channel working fine, is it running or not, and then from in that channel how many transactions are actually received, and then is there any issue with recent transaction when you are applying it. So this is this one. So if you have an error, let's say there is some issue when you are giving a user a password or the code, something. So that channel will be down, and if you don't know how what is the reason channel is down, you can go to this table and look into this three things which will give you what is the error number and what's the error message and at what time it happened. So individual channels you can monitor using these things. Connection status.
But even with the connection error, the status will be on service state.
Yeah, that is actually. So now you have, right? So immediately after you get the error, the channel will be, service state will be off, thread ID, there will not be any thread ID, this one will be off. So this is the final state if you have an error. You can see that service state is off, something went wrong, you can see the error also. Yeah.
So Venkatesh, this basic show slave status, it will show the same output or it shows different?
Yeah, so slave status actually, there is one column added at the end for the channel name. So you have almost like 55 or 56 in the source slave status. All those 55 will come and then channel name. And then again for the channel 2, again you will get all those 55 for the channel 2, and then there will be a channel name. This is a table format which is easy for you to debug and then easy for you to look into it. You can even query just the last error timestamp. It's like a table. You can just create. As you know, source slave status is kind of, when it comes to the multi-channel thing, there will be so many things, it will be very tough for us. So we have introduced these things.
But the information will be same, right?
Information will be same. All these things you can find it on the source slave status as well. We added the channel name at the end for the backward compatibility. So this is what I want to cover for multi-source replication, and these are the blocks. I think we will be sharing the slides in Facebook Usercamp thing. So these are the blocks which the developers has written, and you can look into these things. The first two are related to the feature, and then these 3 are related to the performance related stuff which we have blocked. So these are the things which are very useful. So that's all I have. Anyone is having any questions?
So it's in PMR or it's in lab?
Yeah, it's in labs. I've covered it in the first. It's in currently labs. You can download it from the labs. 575 labs multi-source replication. You will get it first page or second page in Google, and you can download it. Any question? Yeah.
We have a setup for monitoring, but is there any provision for retry limit, like after this duration start retrying or connecting it?
For the monitoring?
After monitoring, if something is failing, so do we have to again go back and make the connections, or is there any retry limit there? Like after this duration, you try again.
Connection retries, I don't think we have, but we have retries in statement level, like there is slave transaction retries. If transaction is failed because of timeout or something else, we have a feature called option called slave transaction retries. If you try it, if there is some problem on the transaction retry, right, it will retry and then it will see if something is working now. But the connection level we don't have.
So we have to manually again configure after monitoring.
Any other questions? Okay, thank you.
So that's all we had today. I, on behalf of MySQL and entire team, extend a very hearty vote of thanks to the fraternity of MySQL gathered today. I would like to express my sincere thanks to speakers, Chaitra, covering the insights about MySQL 5.7 optimizers, and Venkatesh for giving a very good expressive details about multi-source replication. I must also thanks to all the guests who have come over here from all the way from their busy schedules. We are so delighted to have you here. I'm sure you would have found these presentations very informative, and we would like to have your feedback to organize this event in future, very informative and in a better way. Finally, a special thanks to Tinku, Priya and other volunteers who coordinated to organize this event. Thanks for making it successful.